So this is the demonstration of my submission for the industrial automation task for 2021, which has to complete these two sequences in order, with the second sequence repeating itself indefinitely until I press a push button switch. As required by the 11 rules, there should be two cylinders, A and B, that are double acting cylinders, two cylinders C and D that are rotary cylinders. Then cylinder A and cylinder D should have valves with spring return, and then the other two cylinders should have normal solenoid return valves as per rule 6. Then a cylinder A should have a sensor that should check if the pressure reached full bar. I have the pressure sensor here that I've called bar, a flow meter that will tell us in real time the pressure so we can visually see it. And I use this throttle valve to reduce the pressure so it's not instant. And I have a quick exhaust valve here so that cylinder B makes a rapid return as requested by rule 9. Cylinder C should also take 2 seconds to return, so I use this throttle check valve. And then cylinder D should have speed control elements, so it takes 3 seconds for it to go clockwise and anti-clockwise. So I have used a combination of 3 different steps to make it as close as possible to 3 seconds and make it so that this 3 seconds is stable and it can happen every single time. One of the problems that I had was that the cylinder would have a random, more or less, time between 2 to 3.5 seconds, depending on the run, which wasn't satisfying and wasn't precise enough. So I've used a throttle check valve with specific values, a variable orifice with specific values, and I have reduced the nominal flow rate of the valve so that it reaches the required 3 seconds. As per rule 11, I'm also using 2 optical switches for C. And then for cylinder A, B, and D, I'm using different labels connected to make switches, which are then connected to relays. In total, there are 11 relays, which are then connected to valve solenoids, which actuate the actual solenoid valves so that the cylinders can go backwards and forwards and change their own position. As required, the supply pressure should have 6 bar, and we can see it here, 6 bar. And there should be 2 lamps, lamp 1 and lamp 2. Lamp 1 which activates during the first sequence, and lamp 2 which activates during the second sequence. And there should be a timing diagram, a state diagram, which shows us the timings of the cylinders. Other than that, there should be electric counters and timers to complete the sequence. I'm using 4 timers in total to complete the sequence and 1 counter as per request, so that this part here of the second sequence repeats. I'm also using for cylinder A 3 different labels, actuating labels, so that the second sequence starts as soon as the cylinder A reaches its initial 0 position. And then I'm also using 3 different labels on cylinder C. I'm using S1 and S2, which are used together with the optical switches. And then this C label, which is being used so that the second lamp turns off only when the user has pushed the PB button, which lets the sequence to come to an end only after it completes the cycle, and then it turns off the lamp. Without this label, the lamp would turn off for like half a second in between every single instance of the repeating sequence. So I'm gonna have a regular one-to-one simulation here, so I can show how it works. So if I press the button, I have B+, A+, full bar, B-, A-, C+, very fast, same with B, D+ and D-. There's a 2-second timer. This is the counter, as you can see, it works. I have a 3-second delay relay here so that the cylinder D can actually reach its final position. I've had a problem where the cylinder D would just go 100 to 80, 100 to 80 and back and forth, and you wouldn't properly complete it. This delay timer connected to a brake switch lets it fully complete. Then 1 second and it stops. And then as you can see, the lamp remains off and then the entire sequence repeats again. Now, if I press the button, I have this push button here. Now the sequence will reach its end, which is C-, and then the lamp will turn off and the entire simulation will stop, as requested by rule 4. So we can see here the 3 seconds, forward, 3 seconds backwards. This is the last time it does it. So it does that. 1 second, C-, and you can see here C- took around 2.1 seconds, more or less. And this has been the full rundown of the simulation of my project for this task.